What you're looking at isn't a construction boom. It's a rescue mission. America is spending more than $500 billion building things many people thought it had forgotten how to build. Chip factories, high-speed rail, massive tunnels beneath rivers, entire cities of servers dedicated to artificial intelligence. And none of it is happening because America woke up one morning feeling ambitious. It's happening because something went wrong. Something visible and embarrassing and dangerous enough that the most powerful economy in the world had to stop and admit it out loud. We made ourselves dependent on everything, on everyone. And if that dependency is ever weaponized against us, by a pandemic, by a rival, by a broken shipping lane, we cannot function. What follows is the physical response to that admission. $500 billion, hundreds of thousands of workers, and a race that has already started. The year was 2021. The pandemic had frozen shipping lanes around the world. Containers sat stranded in harbors. Lumber prices tripled. And then, quietly at first, car factories across America started going dark. Not because of missing steel, not because workers stayed home, but because of a component the size of a thumbnail, a microchip. Ford lost $2.5 billion in a single quarter. General Motors shut down 8 production plants simultaneously. Hospitals couldn't procure ventilators. The Defense Department quietly flagged that key weapons systems depended on chips made exclusively in Asia. The realization landed hard. The most powerful military and economic force in human history could not build a car, a fighter jet, a phone, or a medical ventilator without permission from factories 7,000 miles away, most of them concentrated on a single 90-mile-wide island called Taiwan. Washington's response was the Chips and Science Act, $52 billion in direct manufacturing incentives. The Inflation Reduction Act added hundreds of billions more for clean energy and advanced manufacturing. Together, they triggered something far larger than chips. They unlocked a cascade of investment across every category of American infrastructure: transportation, energy, computing, aviation, that is now converging into the most technically complex construction surge in modern American history. Start in the Arizona desert, north of Phoenix, on a stretch of scrubland that 2 years ago had nothing on it. Today, it is one of the most consequential construction sites on Earth. Every morning before sunrise, more than 10,000 workers arrive at the TSMC Fab 21 campus. Electricians, pipe fitters, crane operators, clean room specialists, engineers sourced from 3 continents. Together they are building what will become the most advanced semiconductor manufacturing complex in American history. 6 interconnected chip factories on 1,100 acres of reclaimed desert. Total cost, $165 billion. More than the GDP of Hungary. More than 20 years of NASA's annual budget combined. The first factory is already producing. Fab 21 Phase 1 runs at 4-nanometer precision, the same process inside the latest iPhones and the AI chips powering the tools millions of people use every day. The second fab completed construction in April 2026. A third is rising now. Here's what building at this precision actually requires. The clean rooms must maintain Class 1 air quality, fewer than 10 particles per cubic meter. A hospital operating theater runs at Class 1000. The floors are isolated from vibration measured in nanometers, because even foot traffic in the wrong corridor can theoretically disrupt what's being made inside. Every pipe, every duct, every cable runs through a building within a building, designed to exclude the outside world entirely. TSMC is also constructing an on-site water reclamation facility. Each fab consumes water at the scale of a small city. Stop here for a moment. Because there is a problem running underneath every project described in this video, and it's not the one anyone expected. It's not money. The money is committed. It's not engineering. The engineering is understood. It's not political will. These projects have bipartisan support and federal funding locked in. The problem is people. At peak construction, the combined labor demand across semiconductor fabs, data centers, tunnels, rail lines, energy infrastructure, and airport rebuilds will require hundreds of thousands of specialized workers, simultaneously. Clean room construction specialists, tunnel boring machine operators, high-voltage electricians trained for data center load requirements, workers who understand the precise sequencing of process utility installation inside a chip factory. These are not skills you develop in 6 weeks. America does not currently have enough of them. The Arizona construction market is so pressured that TSMC brought in specialized crews from Taiwan to supplement local labor. The Gateway Tunnel in New York is competing for the same tunneling specialists as simultaneous projects in California, Texas, and Boston. The money exists. The plans exist. The projects will be built, but the bottleneck is human, and it is real. And the strange part is that even if America solves the labor shortage, another bottleneck is already appearing. Electricity. Every message you send, every video you stream, every question you ask an AI, that request travels to a building. A specific kind of building that never sleeps, never pauses, and consumes electricity on a scale that would have seemed impossible 20 years ago. America is currently building more of these buildings than at any point in history. Amazon's Project Rainier in Indiana occupies 1,200 acres, larger than many American towns. 30 data center facilities at full build-out, 2.2 gigawatts of continuous electricity demand, enough to power more than 1 million homes, running, every hour, forever. Meta's campus in Lebanon, Tennessee is 4 million square feet across 1,500 acres, 13 buildings, 1 gigawatt of capacity, 4,000 workers on site at peak construction. It is being built to run AI systems that do not yet exist. But here's the part that doesn't make the press releases. These facilities don't just consume electricity, they're now beginning to compete with entire cities for it. Utilities in Indiana, Tennessee, and Virginia are fast-tracking new generation capacity, specifically because data centers are arriving faster than the existing grid can absorb them. A single gigawatt campus generates so much waste heat that its cooling systems move water at the scale of a municipal utility. They're not server rooms anymore. They're the heaviest industrial buildings on Earth, and they're still multiplying. Now go underground, 100 feet beneath the Hudson River, beneath active shipping traffic, beneath a century of buried infrastructure, sit 2 rail tunnels built in 1910. Every single day, 200,000 passengers move through them. Every morning, dispatchers overseeing the Northeast Corridor manage the same uncomfortable reality. The tunnels were damaged by Hurricane Sandy in 2012, have been running at reduced capacity ever since, and carry a corridor that generates 17% of the entire U.S. economy. Engineers have been direct about what happens if one structurally fails. It would be the equivalent of permanently closing the busiest airport in the world. The economic damage to the Northeast megaregion, New York, New Jersey, Philadelphia, Boston, Washington, would be catastrophic and sustained. The Gateway Hudson Tunnel Project is the $16.1 billion solution. 2 entirely new tunnels, bored beneath an active river without stopping the trains running through the ones beside them. The engineering method uses tunnel boring machines, rotating mechanical cylinders the diameter of a 4-lane road, that cut through earth and install concrete ring segments behind them simultaneously. Like threading a pipe through soil without disturbing the surface above, the geology beneath the Hudson is uncooperative. Soft river sediment, ancient bedrock, buried debris from over a century of construction. Before boring begins, grout must be injected into the riverbed to stabilize the ground around the machines. Every advance is calculated to the millimeter. The Hudson Yards concrete casing, the critical final link into Penn Station, is already over 50% complete. For most of its history, America has had a relationship with high-speed rail that follows a consistent pattern. Study it, plan it, debate it, delay it, study it again. Brightline West broke that pattern. It is a $21 billion project connecting Las Vegas to the edge of Los Angeles. 218 miles of high-speed rail running at up to 200 miles per hour. And it is, as of right now, the only true high-speed passenger rail project in American history that has actually reached full construction. Every other proposal is still in a planning document somewhere. The route runs directly through the median of Interstate 15. That choice is deliberate. The land already exists as a public right-of-way. No eminent domain battles. No routing disputes through neighborhoods. The highway handed the project a 218-mile construction corridor without negotiation. Building inside an operating interstate brings its own complications. Crews work separated from live traffic by barriers, in desert heat that regularly exceeds 115 degrees Fahrenheit. Steel rail expands and contracts in that heat, requiring specialized anchoring systems to prevent buckling. The route climbs through the Cajon Pass, demanding precise gradient engineering for trains at speed. When it opens, 3 million cars are expected to leave I-15 every year. Every Friday afternoon on the drive between Los Angeles and Las Vegas, the highway that becomes a parking lot for 50 miles, will eventually have an alternative running beside it at 200 miles per hour. JFK International Airport is the primary gateway into the largest city in the Western Hemisphere. For decades, it has also been, by most measurable standards, an embarrassment. A patchwork of mismatched terminals, with no unified design, poor ground connections, and a passenger experience ranking near the bottom of major international hubs. The $19 billion JFK Master Plan is the overdue correction. 4 new unified terminals, express rail to Manhattan, flood resilience for the next century. The engineering constraint is the one that makes airport rebuilds uniquely brutal. JFK cannot close. Not for a single day. Every crane, every excavation, every concrete pour must be scheduled around 65 million annual passengers still moving through the site. Initial gates open in 2026. Full completion in 2030. There is a dependency problem embedded in everything described so far. Semiconductor fabs consume electricity at the scale of small cities. Data center campuses demand gigawatts of continuous power. High-speed rail runs on electricity. EV battery factories run on electricity. The construction equipment building all of the above runs on diesel, with electrification following close behind. And America's power grid, much of it built in the mid-20th century, designed for household appliances and light industry, was never engineered for this. So the same surge rebuilding chip supply chains and computing infrastructure is simultaneously forcing a parallel rebuild of the energy system itself. The SunZia project in New Mexico is an $11 billion wind farm and transmission line combined, 3.5 gigawatts of generation capacity paired with 550 miles of new high-voltage transmission running into Arizona, directly toward the fabs and data centers consuming it. One of the longest new transmission lines built in the United States in decades. Expected operational in 2026. In Tennessee, the Kingston Energy Complex is retiring 9 coal-fired generating units and replacing them with an integrated combination of natural gas, battery storage, and solar. The machines need power. The grid is being rebuilt to provide it. Step back and look at what all of this adds up to. None of these projects exist because America decided to build something impressive. They exist because America mapped where critical things were made. Chips in Taiwan, batteries and solar panels concentrated elsewhere, rare earth processing overwhelmingly outside U.S. borders, and drew the obvious conclusion: economic strength and physical manufacturing capacity are the same thing. You cannot separate them. The TSMC Fab is not a real estate development. It is a national security asset. The Gateway Tunnel is not a commuter convenience. It is the circulatory system of an economic zone that generates 17% of U.S. GDP. Brightline West is not a novelty. It is proof that something genuinely new can still be built here. Other countries are not standing still. They are building manufacturing capacity, rail networks, and industrial infrastructure at extraordinary speed. The difference now is that America is building too. The projects described in this video will still be operating in 2075. The chips made in Arizona will power technologies not yet imagined. The tunnels bored beneath the Hudson will carry passengers whose parents are in school today. 50 years from now, most people won't know the names of the workers pouring concrete in the Arizona desert before sunrise, or the engineers calculating millimeter advances beneath the Hudson River, or the electricians wiring data centers in the Tennessee heat. They'll use the chips, ride the trains, fly through the terminals, and most of them will never realize the world around them was rebuilt before they arrived.